So in the previous lesson, we have learned how to determine whether a series is absolutely convergent or divergent. So by examining the behavior of its terms. However, not all series can be easily analyzed using comparison or limit comparison tests. So now we're going to discuss about the ratio and the root test, which are useful in determining whether the given series is an absolute convergent. So here on screen we have the ratio test. So these are the considerations in using the ratio test. First is if limit n approaches to infinity, an plus 1 over an, so it's equals to L less than 1, then the series summation of a sub n, where n is equals to 1, is absolutely convergent, and therefore it is convergent. So second, if we can use the ratio test, if the limit of n approaches to infinity, the absolute value of a sub n plus 1 over a sub n is equals to L greater than 1, or limit n approaches to infinity, summation of a sub n plus 1 over a sub n is equals to infinity, the series summation of a sub n, where n is equals to 1, is divergent. So another thing to consider when we use the ratio test in concluding is that if the limit of n approaches to infinity, absolute value of a sub n plus 1 over a sub n is equals to 1, the ratio test is inconclusive. That is, no conclusion can be drawn about the convergence of or divergence of the summation of a sub n. Now we have here an example. First is test the series of summation of negative 1 raised to n multiplied to n cubed over 3 raised to n, as n is equals to 1 for absolute convergence. So in our solution, we use the ratio test. So we set an is equals to negative 1 raised to n multiplied to n cubed over 3 raised to n. So we have here a sub n plus 1 over a sub n, as it is the ratio test, so we substitute it. So we have here for a sub n plus 1 is equals to negative 1 n plus 1 multiplied to n plus 1 cube over 3 n plus 1. That is for our a sub n plus 1. So for our a sub n, we know that it is equals to negative 1 raised to n cubed over 3 raised to n. So to simply operate this, we get its reciprocal. So for simplification, we now have n plus 1 cubed over 3n plus 1 multiplied to 3n over n cubed. So we have now 1/3 times n plus 1 over n cubed is equals to 1/3 times 1 plus 1 over n cubed. So we have here 1/3 less than to 1. So thus, by the ratio test, the given series is absolutely convergent. Another example is test the convergence of the series summation of n raised to n over n factorial, as n is equals to 1. So for our solution using the ratio test, since the terms a sub n is equals to n raised to n over n factorial are positive, we don't need the absolute value sign because it is already positive as from the given. So by the ratio test, we have a sub n plus 1 over a sub n. So we have n plus 1 raised to n plus 1 over n plus 1 factorial multiply. So we simply reciprocate it to easily operate the operation. So we have multiplied to n factorial over n raised to n. So we have now n plus 1 times n plus 1 raised to n over n plus 1 n factorial multiply to n factorial over n raised to n. So we have now n plus 1 over n raised to n is equals to 1 plus 1 over n raised to n, and it is resulting to e. So as n approaches to infinity, since e is greater than 1, the given series is divergent by the ratio test. Now for root test, these are the bases in concluding when we use the root test in our given series. So first is if limit of n approaches to infinity, square root of absolute value a sub n and is equals to L less than 1, then the series is summation of a sub n is absolutely convergent and therefore convergent. If in the second hand, we have here L, if the limit is greater than 1, so and or the limit of n approaches to infinity, the square root of absolute value of a sub n is equals to infinity, then the series is divergent. So if the L naman is resulting to 1, so the root test is inconclusive. Same with our ratio test. So if limit n approaches to infinity, square root of absolute value a sub n is equals to 1. So the part 3 or katong the root test is inconclusive, it says that the test gives no information. So the series of summation of a sub n could converge or diverge. So if L is equals to 1 in the root test, don't try to root test because L will again be 1. And if L is equals to 1 in the root test, don't try to ratio test because it will fail too. So that's the consideration we need to keep in mind. Now for our root test, we have here test the convergence of the series summation of 2n plus 3 over 3n plus 2 raised to n as n is equals to 1. So for our solution, using the root test, we set a sub n is equals to its original given, which is the 2n plus 3 over 3n plus 2 raised to n. So square root of absolute value of a sub n, so we have here 2n plus 3 over 3n plus 2 is equals to 2 plus 3 over n over 3 plus 2 over n as we divide each into n. So that is the result, and we remain it by 2/3. So as 2/3 is less than to 1, thus the given series is convergent by root test based on the consideration that we have earlier. So always remember the consideration, the list that we have earlier about the ratio test and the root test in order for us to know what is the conclusion of the given series when we are asked to solve for one. So that's all. Thank you.